Hello dear students, this is lecture 20 and in last lecture 19 we discussed about horse and cart problem. We are continuing our chapter 3a. In this lecture we will discuss apparent weight of man in lift or elevator and we will discuss about the connected motion. First of all, let us discuss apparent weight of a man in a lift. Consider a person in a lift and case 1 when the lift is accelerating upwards. When lift is accelerating upward, the first weight mg of the person is in downward direction, and due to acceleration of lift, the pseudo force or the reaction will also be in downward direction. So person weight will feel to be mg plus a. Hence the apparent weight becomes mg plus a if the a is the acceleration in upward direction. तो आपने भी ये फील किया होगा कि जब आप लिफ्ट में जाते हैं और लिफ्ट ऊपर की तरफ उठती है तो आपको आपका वेट आपके पैरों पे थोड़ा सा ज़्यादा फील होता है. एंड इसका रिवर्स होगा व्हेन लिफ्ट इज कमिंग डाउनवर्ड, बिकॉज व्हेन लिफ्ट इज कमिंग डाउनवर्ड विद एक्सेलरेशन ए, ड्यू टू दैट acceleration body will feel an upward force ma. Gravity is always working in downward direction, so considering g greater than a, apparent weight becomes mg minus a. When acceleration is 0 or the velocity of elevator is constant and the velocity 0 case is also included in this, then your apparent weight is equal to actual weight, same weight as per regular g. Under free fall, your a is equal to g and apparent weight becomes 0 as w dash is equal to w g minus g, that is 0 because a is equal to g. If downward acceleration is more than g, then weight in lift become negative. Let me explain you this portion. Consider this is the lift and a person is here in the lift. If the lift is moving downward with an acceleration g, or lift is moving downward with an acceleration a which is greater than g, then person will experience a force in upward direction, and as weight is mg downward and ma force is in upward direction, as your a is greater than g, ma is greater than mg, and the person will feel a negative weight in upward direction m a minus g. So if we will put the value in previous formula, that mg minus a, and as our a is greater than g, this term will come minus m a minus g. So this is going to be apparent weight w dash, which is negative. So m a minus g weight of the person will be on the ceiling of the lift. Next is principle of conservation of linear momentum. This is not new. You must have studied in class 9th that recoiling of gun is due to momentum conservation, and when you step from the boat on the shore, the boat goes back due to conservation of linear momentum. According to the statement, in an isolated system, the vector sum of linear momenta of all the bodies of system is conserved and is not affected due to their mutual action and reaction. So summation of all the momentums in an isolated system is always 0. What is recoiling of a gun? Recoiling of a gun is indicating same. There are few examples of momentum conservation. Before firing the gun, momentum is 0, and after firing, let us consider m1 is the mass of bullet and v1 is the velocity, and m2 is the mass of gun and v2 is the recoil velocity of gun. Then after firing of bullet, momentum must be equal to 0, so their sum is compared to 0, and by this relation we can calculate v2 is equal to minus m1 v1 divided by m2. While firing, the gun must be held tightly to the shoulder so that the m2 value will become greater. Mass of your body will get attached to it and it will have lesser recoil velocity. Flight of rockets and jet planes are based on principle of conservation of momentum, or we can say Newton's third law of motion. So when gases comes out from the rocket at very high speed, due to momentum conservation, rocket moves upward. When a man jumps out of a boat to the shore, boat generally moves backward, and It is because of momentum conservation, because person and boat are almost in rest and having zero momentum. When person moves, the boat moves in reverse direction, making some of the momenta zero. When a bomb is exploded, you might have seen particles scatter in different directions. They scatter generally like this, that their sum of momentum is zero. If a particle is scattered on left, then there must be some b particle which is scattered on right. Or if the particles are greater than 2, they will scatter such that the vector sum of their momentum will remain zero or same. A person, if it is left on a frictionless surface, can get away by throwing objects in opposite direction using principle of conservation of momentum. Next is second law of motion is known as real law of motion, because first and third law are contained in this. Let us have a look. We have studied that impulse is defined as force into time, and impulse is change in momentum. So if impulse is change in momentum and momentum remains conserved, so impulse must also remain conserved. So impulse on both the objects, the sum of impulse must be equal to 0. Comparing this, we get F1 is equal to minus F2t, which is nothing but Newton's third law of motion. Action is equal to opposite reaction. So this is how first law is contained in the second law of motion. Similarly, this is your third law of motion, which is contained in second law of motion. Similarly, we know that F is equal to ma, and if F is equal to 0, a is equal to 0, which means v can be constant or 0. So which is indicating no velocity state of motion or rest can be changed. No velocity can be changed without application of any external force, which is nothing but Newton's first law of motion. Hence first and third both laws are contained in the Newton's second law of motion. Next topic is connected motion. It is quite easy, just pay attention, otherwise you will get stuck in this derivation. Consider an arrangement as shown in figure where m1 mass is greater than m2. So the m1 is going downward with acceleration a, and at the same time your m2 mass is moving upward with acceleration a, as they are tied with the same string, and the tension in the string is T on the both sides. So for mass m2, if I will apply the equation, m2g is the force in downward direction and tension is the force in upward direction. And as the object is moving in upward direction, so T is greater than m2g. So T minus m2g is equal to m2a is my first equation. Similarly, for m1g, as it is moving downward, m1g is greater than T, and m1g minus T is equal to m1a, where a is the acceleration. Now, after having these two equations, if we will add them, we can see that when we will add them, the tension variable will get eliminated when I will add them, and I will be having m1 minus m2g is equal to m1 plus m2a from the right hand side, and acceleration can be find m1 minus m2g divided by m1 plus m2. So this is your formula of acceleration. If you divide equation 1 by 2, your a variable will get eliminated, and by cross multiplying and then moving the terms with the tension on left hand side and then taking all the terms on the right hand side, we can derive the formula of tension. T is equal to 2m1 m2g divided by m1 plus m2. After this, the next topic in book is your numericals on equilibrium of forces, which we have discussed in previous lectures. So try the homework is solved example problems. The pages I am sharing with the notes and video lecture, and try problems for unsolved problems also, but solved examples you must do in your first attempt. Thank you. We'll see you in next lecture.